Welcome, this is Dr.M.NALINI, Associate Professor, Department of Computer Science and Business System, S.A. Engineering College. Today we are going to solve some GATE questions relevant to algorithm subjects. So this is the syllabus for the algorithm. The first topic we are going to see about searching. In the last video already we saw about what is searching and what are the types of searching. There is two types of searching will be there. One is a linear search, another one is a binary search. Already we saw what is linear search, how it will be work, and what all the problems we can able to solve with the linear search. Everything we detailedly seen in the last video. So now we are going to see about the next type of searching, that is binary search. So today we are going to see about binary search. Binary search is an effective searching algorithm. Compared to the linear search, it is very effective. Why we are telling like this means we can easily find the target element with the comparative sorted element. So it is dividing the entire sorted string into two half. We can able to sort only one half to find the particular searching element as possible with this binary search. How this binary search is going to be work? So the first step, we need to divide the search space into two half. So we are doing like this, then we can able to find the middle index of the particular search space. Next we are going to compare that middle element with the search key element. So if the search key element and the middle element is same, then we are going to terminate the process, because whatever the search key we are find out. So we are going to terminate the process, or else otherwise if the key is not found, that is not matched with the middle element, then we need to check whether the key is smaller than the middle element or the key is larger than the middle element. If it is the key is smaller than the middle element, next we need to continue our search in the left side off. Next, if suppose the key is larger than the middle element, next we need to start our searching in the right side off. So based on that we are doing the searching process again with the middle element and the key element. If the key element is matched with the middle element, we are going to stop our process. The result is we found the particular searching element. So how it will be works, that we need to see with one sample example. See here, so initially they are given the sorted array, that is 2, 5, 8, 12, 16, 23, 38, 56, 72 and 91. Here they are given the search key finding element as 23. Now we need to do the middle element search. The middle element we need to find the entire array. The position is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need to take an as half of this array. In the half of the array means first one is the 0 and the half of the middle element is 4. So what is our key element? That is 23. So we need to compare with the key element with the middle element. So what is present here in the middle element is 16. Our key element is 23. We need to check whether this key element is middle element is 16, that is we need to check with the 23 if it is smaller or larger. If it is smaller, already we saw the algorithm, we need to go it into left hand direction. If it is larger, we need to move on into the right hand direction. So see whether the next step, the key element 23 is larger, so that we are moving on into the right hand side direction. In the right hand side direction, see whether already we saw the 0 is the first position, 0 is the lowest element, and 16 is the middle element, and the 91 is the last element. Likewise we are doing the comparison. The 16 is the middle element. We are checking whether the 23 is greater than the 16, so that we are going to do the comparison is only for the right hand side. In the right hand side, this half we are taken as one sorted array. In this array we are going to do the searching. So here is the lowest element is 23. Here the highest element is 91. Here we need to find the middle element. That the middle element is the position is 7. So in the 7th position, what will be there? The value is 56. So now we need to check whether the middle element and our key element. Our key element is what? 23. We are comparing with the 56. Which one is? If it is equal, first we need to do the checking as it is equal. If it is not equal, we need to check whether if it is greater or lesser. That we need to check. Suppose if it is lesser, we need to move on our search into left hand direction. So if it is less, so we are moving on into the left hand position. What is the left hand position here? We have so 23 and 38. This is the left hand portion. So in the 23 and 38, we need to find the first element and the last element and the middle element. So this is the first element and this is the last element and this is the middle element here. Because only two elements will be there. So 23 is the middle element. So we are going to check with the middle element and the key element. So the key element is 23 and the middle element also 23. So now we need to terminate the process. We find out the particular searching element. So likewise we need to complete the searching based on the binary search. Now we are going to see about the complexity of the binary search. So first we need to take care about the time complexity. In the time complexity, what is the best case and worst case we need to be seen. So the best case of the time complexity in the binary search we called as order of 1. How we will say that this is a best case? The key element and the first searching middle element is same, then we called as that is the best case. Okay, that is the time complexity is order of 1. What is the worst case we are telling? Which one? The key element and it will be matched with the searching element. So either if it is a first element or it is a last element in the sorted array. Our key element will be present in the first position or the last position in the sorted array. We called as that is first case. What is the best case? Our key element and our middle element of the search array is same. That is we called as the best case. Next is the space complexity. We are telling us the acceleratory space. In the recursive call stack is considered that the acceleratory space will be order of log n. Because of the time complexity is order of 1, so the acceleratory space value will be order of log n. So how to implement the binary search? We can able to implement the binary search in the coding two ways. One is the interactive binary search algorithm, another one is the recursive binary search algorithm. Iterative binary search algorithm. What does mean by iterative? Already we know iterative means again and again we need to make a call and increment and we are going to do the searching, that is we called as iterative. So here we are telling us in the binary search iterative, how it will be means we are using the while loop concept here. For the looping means what is the purpose? We will do the increment and we are keep on checking the key value is matched with the middle value, if it is satisfied or not. If it will be less than, we need to move on into this direction. If it is greater than, we need to move on into this direction for searching. Likewise, we are doing the increment and we are keep on searching the elements, that is make use of iterative method. That is here we are using looping concept, that is while loop we are using. Like that kind of way we are implementing the binary search, we called as that is iterative binary search algorithm. Next, recursive binary search algorithm. All know about what is recursive, right? If we are calling again the same function again and again with the same name, that is we called as an recursive. So here we are using the binary search as a function name for finding the key element. The same binary search value we are calling inside the same function we are using, and recursively we are calling the same thing again and again, so that this kind of way we are finding the binary search answer, that is we called as recursive binary search algorithm. Now we need to see about what is the advantages and disadvantages of the binary search. Already initially I say that what is the advantages of binary search. We are compared to the linear search, binary search is very fast compared to all other search, and it is very effective compared with the time complexity. The same time complexity is having interpolation search and the exponential search. The time complexity of the binary search is same, but it is very effective compared to these two searches. Compared to linear search, it is very fast and effective. It can be easily handle large array data, that is also possible. And this is well suited with the large data set to find a particular element in the sorted array. Okay, the large data set, but if it is in the way of sorted external memory or internal memory, especially for odd disk concept, we can easily find the particular element. Make use of binary search is possible very easy. Here we are going to see about disadvantages. In the disadvantages, the first one is, the thing is, it is working only with the sorted array. Unsorted array, it is not possible to do only with the sorted array. And another one thing, the continuous memory location. If it is a starter array and the values are stored in the continuous memory, then only we can able to make it as finding the particular searching element as possible. Another one thing they are telling us, it will be requires compared to the other elements array, comparably it must be able to be a ordered one. Unordered one, it is not possible. So the elements are in ordered and it is in sequence one, then only it is possible to do. That is, we say that this is the important disadvantage of here. So what are the applications we are applying binary search concept here in the real world? If we see, the binary search can be used in building blocks of more complex algorithms like machine learning. Now we know about what is machine learning and how we are training all the data with the machine learning and how we are using it here in the real world. So in this concept, in the machine learning algorithms, using the binary search to finding the particular elements. In the machine learning, especially for neural networks, in that portion it will be very useful. It can be used for searching the computer graphics such as ray tracking and texture mapping. So ray tracking and texture mapping in the computer graphics field, the binary search is very useful to finding the elements. It can be used in searching a large database. We need to find one particular elements, that is possible with this binary search concept. Now we are going to solve some gate questions relevant to this binary search. So we are going to see about the first question. What is the first question here present? The increasing order of performance of the searching algorithms are. So what is the order we need to find? So first here we are mentioning only 3 searches. We know about all these searches. One is the linear search, another one is the binary search, another one is jump search. 3 searches we are given. Already we know what is linear search and what is binary search and what is jump search. Based on the time complexity values, we will take up and we can easily say whether which one is good performance. Linear search, compared to linear search, binary search is the best. Already we saw this for the entire thing in the session, because of it is dividing. For the linear search, it will be searching for each and every elements in the array. That is the way it will be searching. The linear search searching each and every elements in the array. After that it will be finding the searching element. But in the binary search, how we will do? We will split it into the entire array space. We are split it into 2. We are making the search with the middle element and the search element first. After that again we are split it into the search space and again we are finding the middle element. Again we are doing the search with the middle element and the key. So we no need to search the entire elements in the array. That is no need in the binary search. What is the jump search? The jump search, it is nothing but it is way of linear search. It will be searching in the block. Okay. So if we have a blocks, 2-3 blocks, then we can taken as one block. The entire array we were splitted into blocks and we are taken as one block. In this block we are making a linear search inside this block, that is we called as jump search. Okay, so in the binary search, what is the time complexity of the binary search? What is the time complexity of the linear search? Based on this, we will come under the conclusion of the performance. The linear search is what? Order of n is the time complexity. What is the jump search? Order of root n is the time complexity. Order of log n is the time complexity of the binary search. So we can easily say that the binary search only taken less time compared to jump search compared to linear search. So what is the answer we can see now? So the answer is the first one. The linear search is less than the jump search and less than the binary search. So this is the correct answer because the binary search alone having less time complexity compared to the linear search, jump search. Linear search is compared to jump search is higher time complexity. Jump search is compared to binary search. Jump search is higher time complexity. So binary search alone having less time complexity. Okay, now we are going to see about the next gate question, that is what the time taken by the binary search algorithm to search a key in a sorted array of n elements. So n elements means what? In the binary search, in the n number of arrays with the n number of elements, we need to make a search. So arrays with the n number of elements means what? We need to split it into 2 half. For any array we need to make a split into 2 half. After that only we can able to make a search. Right, that is the way of searching in the binary. So we no need to search the entire thing. So we need to search only the half of the array we are taken it and we are going to do the search. So that based on that n element with the half condition, we know that the time complexity is log to half. So that log to n. Now we are going to see about whether this answer is right or not. See, yes, the answer of this n sorted array element time taken is order of log to n. Okay. Next, the third question, the necessary conditions for using binary search in an array. So what is the necessary condition for binary search means? What is the first thing they are telling here? The array should not be too long. The array should not be too long. Like that, any condition they are specifying? No. For large size of database with the large size of array, we can able to make it as with the binary search is possible. So this is not a correct option. Next, the array should have more size. So there is no restriction for more size. If it is a small size element with the 2 element also, we can able to make it to find the search element as possible. So this is also wrong element. So next, what is the array should be sorted? Yes, of course. The binary search means what is the important thing? The array is a sorted array. Then only we can able to do a binary search is possible. Sorted array with the continuous memory location only we can able to make it as is possible. So this is the correct answer. Once we will check whether if it is correct or not. Yes, of course, the array should be sorted, then only it will be correct. Okay, now we are going to see about the next question, the question number 4. So what they are telling here? Given the sorted array 10, 20, 30, 40, 50, 60 and the target is what they are given here? It is 50. What is the output of the binary search here? They are telling. So we need to find whether, so first 10, 20, 30, 40, 50 and 60. So we need to find whether what is the answer. So 10 as in the position of array 0, 1, 2, 3, 4, 5. So here the key element is 50, where this key will be present in which position, that alone we are going to search now. So first we need to find the first element, last element and middle element of this given array. So this is the lowest first element and this is the last element, and which one is the middle element we are going to find now. So here 1, 2, 3, 4, 5, 6 will be there. So here which one is the middle element? This 30 will be the middle element. So we need to find whether 50 is greater than or less than 30, that we need to check now. So 50 is larger than the middle element. So larger than the middle element means which portion of the search space we need to take, left or right? So right portion. If it is larger, we need to take right. If it is smaller, we need to go on to the left. So if it is larger, so that we need to take it as only this portion. So in this portion, what all the things will be there? So now this is our first portion. This is our last portion. What is the middle portion? This is our middle portion. Now we need to do the comparison of the middle element with the search element. What is our search element? 50. And what is our middle element here? 50. So what is the meaning? Both are same. Both are same means what? The condition is terminated, because we find out particular search element. In which position it will be available? It is available in the fourth position. So here the answers will be the 4, 5, 3, 1. So the correct answer is 4. Check whether our answer is right or wrong. Yes, of course, this is the correct answer. The 4 is the correct answer. So this is the right answer. Okay. Thank you all for this. We will continue the remaining topics in the next session. Thank you.